All right, hey there, sixth graders, it's Mr. Byrne. We are starting a new unit today, and it is my favorite unit to teach, I think. I can't think of anything I like better because we're doing some geometry today, and I love geometry. I don't know why, but just so you know, it's my favorite. I think it just makes sense in my head, all the shapes, we use it a lot, I don't know, I like it. So, let's get right in there so I don't make this video too long because I'm afraid I'm gonna be a little long-winded. We're starting with area today. We're gonna start talking about area. So the first thing I want you to do is think about what you learned in fifth grade about area and how you write the answers to area. So when we're talking about area, area is the amount of space something takes up on the page. Now I say that as in the amount of space, the amount of two-dimensional space, okay? The amount of squares. The amount of square units that something takes up, okay? Square units. So we use area to talk about like the area of your yard or the area of the room. Like if you look around your classroom right now or your bedroom, wherever you're at, how many square foot is your bedroom? How many square foot is your classroom? Okay, so area is written by square units. How many squares actually fit in there? If I took a square foot, like a foot on each side, and put it all throughout the room, how many could I fit? You can write this a couple ways. You can write it like this, where it says square units, or you could write units squared. Remember our exponents? That means squared. So for example, if it was inches squared, we're gonna do that in here in a minute, I could write inches squared. That means 1 inch on this side and 1 inch on this side. Or I could write square inches. These are the same thing. That's kind of off-centered, but you get it. Square inches or inches squared. That equals that. If it was square feet, it would be a much bigger square. All right? So I have some example things here. Let's start with a nice, easy rectangle because everybody should remember how to do that, but we're going to review it just to make sure. Remember, we have our squares here, right? So if I were to find the area, I could say how many squares are inside, and I could go through and count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 1, 2, 3, 4, 5, 6, 7, 8, 9, 30. So I counted 30 squares in there, so the area would be 30. That's an ugly marker. Square units. Now, I don't know if it's inches exactly, but I could guess it probably is. The easier way to do that would be to use a formula though. And I'm sure a lot of you know this. This is just a review, but if I count how many units are on one side and how many units are on the other side, I can multiply them. So I can go 1, 2, 3, 4, 5, 6. So it's 6 units. Let me get a better marker or a pen. 6 units. And then on this side I have 1, 2, 3, 4, 5. So 5 units. And I can say, well, 6 times 5 units. So 6 times 5 is 30 units squared, or square units, because there's 30 squares. That's literally what it means, 30 square units, or 30 square inches in this case. All right, so there's your rectangle. We've done that. That's fifth grade. Today, we're going to talk about parallelograms. All right, now parallelograms might seem confusing. You might be like, I have no idea what to do with this, but it's really not so bad. When you're working with a parallelogram, it's still a quadrilateral, and quadrilaterals all kind of work the same way. You just have to know which measurements to use. So the equation for a parallelogram is the base times the height. okay? So it kind of looks like algebra. We got some variables in here. Base times the height. You might see it written as just area equals base times height. Remember, you can put letters next to each other and we're good to go. That means to multiply. So when I say the word base, that means the bottom of your shape, okay? If it were sitting flat, if you had something and it was sitting flat on a table, that's its base, right? So this right here is its base. And we know that, well, from this very edge, it's 1, 2, 3, 4, 5 units. And now we need the height. The height is marked from the very bottom, from the base, up to the tip top, okay? A lot of people want to confuse this as the height, but this isn't really the height because it's slanted, right? Imagine it as if you're like slouched over, your height looks a lot shorter, but your actual height is just straight from here, okay? So what I'm gonna do is I'm gonna draw a little dotted line, and you'll see this a lot of times, a dotted line just like that. You might not be able to see that very well. And that is called your height. It is perpendicular. If you remember that term, it means it's a right angle from the base. So it goes straight up from the base. So if I count from there, I count 1, 2, 3, 4 units high, okay? So I have 5 units across and 4 units high, and I'm gonna multiply those. I'm gonna label this height also. So 4 times 5, easy, 20. Now you can't just write that. I need to write units squared, or 20 inches squared in this case. And that's how parallelograms work. Now, if you're like all of a sudden like, how am I supposed to know that? Well, let me show you a little trick here. So I have my little parallelogram, right? If you have your base times your height, imagine it like this. I said a quadrilateral always follows the same rules. There they are. So pretend you have this part of your quadrilateral and this part of your quadrilateral. We could just cut this side right off here. Okay, and I'm gonna slide it over there. And now we can literally count the squares inside. Back here, if I said, okay, how many squares fit inside, you might be like, well, 1, 2, 3, 4, and like 3/4, and then like maybe that one fits together a little bit. But I can move this right over here. It's the exact same size. It takes up the same amount of space, and now I can count my squares. There's 1, 2, 3, 4, 5, 6, 7, 8. That fits together. 10, 11, or sorry, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. Isn't that what we found for our area over here? 20 inches squared. This is still a parallelogram, even though I moved it apart. I took this triangle and moved it over here. It's exactly the same size. All right, I could put it like this, I could put it like this. It's still gonna be the same size, but this makes sense because a rectangle and a parallelogram are basically the same thing. They're just one triangle is moved, okay? So that's how parallelograms work. You just have to remember base times height. All right, these are gonna be mostly what you see today, and this is my last example. You'll see something that looks like this. And it might confuse you a little bit because there's more than one number. You just have to remember which numbers you want to use. What would the base be on this parallelogram? Well, if I were to set this parallelogram flat on something, if I were to take it and just set it down, it's going to sit right on the bottom. Well, that one doesn't have a number. Okay, well, we know by the rules of parallelograms that this number has to be the same as this one. So I'm just going to write a 10 down here to remind myself that it's the same thing. That's 10 feet right there. Well, I know that I don't want this crooked line here, so I'm going to cross that one out, because that right there, my height with my 90-degree angle, that's the number I want. So if I say my area equals my base times my height, then I'm going to say, okay, well, my area is going to be base 10 times my height, 4. So the area equals 40. Okay, what units are they? This says it's in feet. And it's area, so it always has to be squared. Area equals 40 feet squared. Okay, or 40 square feet. I know that that was a lot of examples, but I like to think that that helped you understand area a little bit more. So please, if there's questions, ask your teacher. And otherwise, good luck on your assignment.